Thank you. Thank you. I'm glad to see there's some people awake this morning. Yay, yes. And am I coming through the PA? I can't quite tell. This is good? You can hear me? Okay, excellent. So as he said, I'm Ben Klang. I'm from Atlanta, Georgia. I have a company there called Mojo Lingo. And I'm also here today in my capacity as the leader of the Adhearsion project. So before I get started, has anyone here heard of or even used the Adhearsion project? One? Okay. All right. Has anyone used Asterisk? Awesome. Good. Okay. So we have a understanding here. So today on this presentation, I'm going to talk about a few things. The first is why telephony, why I'm passionate about it, why I find it very, very fascinating, why I think you'll find it fascinating. We'll talk about what a voice application is. Does anyone here does anyone have a concept of what a voice application is, or does it sound like I'm just making up terms as I go? Yeah, okay. Well, we'll talk about what that is. And then I'm also going to talk about why I think Adhearsion is the modern approach to building voice applications. So to start talking about why telephony, we're going to go back in time to the really dark ages before the year 2000, back when telephony was a very scary place to be. We'll start with TDM, PBX, I'll throw out some other letters, PSTN, PRI, DTMF, all these acronyms. Guessing at least a lot of you have no idea what they are. I have a pretty casual grip on some of them myself. But the point is that it was very complex. All of the networks that were used to connect people to each other were controlled by monopolies. You had to have equipment that was certified by the regulatory agencies to even be a part of the network. And all of this basically added up to it being very, very expensive. In addition to just the cost of the circuitry, the equipment you had to use because of the certification process and because of the lack of open standards, everything was proprietary. If you bought, for example, a Panasonic phone system, and I'm not picking on Panasonic, that's just one common manufacturer of that era, anytime you wanted to buy equipment to go with that system, so example, you bought an office telephone system and you wanted to add a new extension for a new hire, you had to buy a Panasonic telephone. There was no standardization. So because there was lock-in between the back end and then the endpoints, everything was, again, very, very expensive. Telephone systems were islands of functionality. They didn't interact much with anything around them. So your PBX, you would stick it off in a corner. It would do some basic things for you. The call would come in. You could route it to your receptionist. She could send it off to someone working in the office. You'd get voicemail. You know, if you're lucky, you'd have some blinking lights to tell you when people were on a call. But it didn't really do much beyond that. All it would do was basically provide voice service. You couldn't integrate with the other things that would run your business. There was not really any API to speak of. Again, you couldn't take, for example, your CRM and tie it into your voice application or your voice system, your PBX, and know who is calling and get any more information about them. There are very few management tools. If a new hire did come in and you were to go set them up a phone, in most cases you needed to call the contractor who installed and maintained your PBX to come out, in a lot of cases actually punch down hard wires to run a phone to the desk. And it just was a big pain. It was, again, expensive because you're paying someone to manage this for you as opposed to having tools that can automate this. So there was no automation. So that's pre-2000. Something kind of magic happened around the year 2000. This is the last 10 years. This is where we've come in the last 10 years, and it's largely responsible, it's largely brought about by the emergence of voice over IP. And in particular, Asterisk and FreeSwitch and SIP. And really, I think Asterisk was the revolutionary change here. Before Mark Spencer released Asterisk, there was no option other than proprietary hardware. When Mark Spencer came about, also with the Tormenta project, which was an open project to publish specifications for how to build the hardware, when all that came about, all of a sudden you had the ability to very inexpensively, like maybe for a couple $1,000s, build a phone system, relative to years before where you might need $20,000 or $50,000 to deploy a phone system. So that was a huge benefit. Standardization on SIP was also an enormous boost. No more do we have proprietary endpoints in the offices. We could use standard open, documented protocols, and those open protocols allowed for new manufacturers to enter the market and to be innovative with their products. So this would mean that the phone that sits on your desk is not just taking calls, but now it has a nice, pretty display, and there are buttons, and you can program those buttons to do things like show you how many callers are waiting in the queue, or announce the incoming call to you, and show who it is and what time and all that. So all of that innovation led to smarter endpoints. So we have smarter phones on the desk. We have mobile phones, which are obviously little computers. Those are moving toward voice over IP modes as well. So we have a lot more capability in the endpoints to do things with phone calls that we have not had until very recently. All of this has led to a convergence of instant messaging and presence within the telephone call. Previously, the telephone call was just one audio connection out to the world. Now we can start to bring in additional information from instant messaging systems like XMPP and presence. So perhaps we make a decision how to route a call based on whether someone is logged into Instant Messenger, or maybe whether they are marked available or away or do not disturb or whatever. And so all of this ties into the beginning of what is truly unified communications. So that's where we've been for the last 10 years. I think the next 10 years is even more exciting. We've laid the groundwork with a lot of technology, and this is where I think we're going to be going with it in the next 10 years. Further decentralization. Right now, even though we are light years ahead of where we were a decade ago, there still is a lot of power concentrated in telephony monopolies, especially in the mobile market, but even in landline. So I think we're going to see more decentralization to where companies can interact with each other and route calls to each other directly. There's a protocol called Dundee, which allows, and Enum, which allow people to actually look up SIP endpoints and route calls directly bypassing the PSTN. There's no reason more that can't happen. We'll see open architectures. Again, with SIP, with things like Asterisk, we'll be able to construct things on entirely open source platforms and deliver calls at fractions of the cost. And again, by saving cost on proprietary measures, we have budget for innovating on things. We'll see more federation, as I mentioned earlier, companies being able to call each other directly, just as you have with email or with XMPP, the ability to basically do a DNS lookup and route messages to that entity without any other configuration. We'll start to see more of the same thing happening with voice over IP. But the exciting stuff is more multimodal integration. Multimodal is kind of a funny word, but really what I'm thinking here is the ability to take multiple multiple communications channels, such as voice, text, video, and then again, as I mentioned, presence, and pull all of those into the context of a call. So you're not just having a voice conversation. You can take that voice conversation, bring it up to a video conference, or maybe you can mix in information from presence so that when someone comes online, you can add them to the call. There are a lot of possibilities here that really just haven't been explored yet. And of course, the ability to collaborate with these new technologies. Desktop sharing and document sharing are more possibilities for that. So for all of these reasons, this is why I think now is a really exciting time to be working with voice. And really, I would even expand this to say working with real-time communications. So that's a bit of a history lesson. I want to talk about what a voice application means to me. A voice application is something that interacts with the audio stream. It's not just a mobile application on your phone. It's not necessarily just an application that runs on a desk phone. It's something that partakes as either a member of the call or working with the audio so that you can add functions and features on top of that. It doesn't necessarily change the audio, and in fact, in most cases it doesn't, but it can. I'll give you some examples of that in a minute. A voice application should also integrate communications channels. As I was talking about earlier, mixing in things like XMPP and presence into a telephone call. A voice application should be able to take into account these things and make decisions on how the call will progress based on those. I would also put into this category talking to outside data sources like databases or web services, being able to pull all these pieces of information in together and enrich the entire phone call. And a voice application should go beyond a phone call. There should be things happening before the phone call ever comes in. There should be things that can happen after the phone call has ended. It's much more than just what happens while the two parties are talking. So let me give you some examples of voice applications. Some of these are from my mind, some of these are actually from projects we've worked on. The first is live translation services. We recently completed a project with a client who wants to build a website where you go and you sign up, and when you're traveling abroad, if you're traveling in a language where you don't speak, if you're traveling in a country where you don't speak a native language, like Belgium, where I don't speak any French at all, I can call a phone number, and that phone number will connect me, based on my account, to a translator who speaks French and English. And then I can ask questions, and usually these are non-emergency type questions, like how do I say I need to find a restaurant, or I'm allergic to peanuts, or what time is it? Things that I don't necessarily need to have answered immediately to keep me out of trouble, but things that will help me enjoy my experience and stay safe and all these things. So the voice application in this case is a matter of knowing who's calling in, knowing what services they need. In this case, the phone service knew that I needed to speak to a French translator based on the phone number that I was calling, and it knew which translators were available, because there are a large number of translators. These guys work with largely college students, people who have a lot of free time in between classes, and they take calls on their mobile phones. So we had to know, based on the ability to sign in and out using text messages or using a website, we had to know who's available. So the voice application would route those calls to individual agents based on their availability, based on their language skills, and all these things. Another example of a voice application could be automated reminder calls. There have been lots of studies that show that, especially with senior citizens or people who have medical conditions, sometimes simply reaching out to them and letting them know that they need to take their medicine, or they need to go see their doctor because it's been too long. These things improve the quality of life. It's a simple application. I mean, this is not exactly groundbreaking, but this is a great example of something you can do with voice that's relatively difficult to do with other communications channels. It's a personal connection. Some things you can also do in the context of a call are what I call mid-call assistance services. So I'm not even sure if that's an official term for it, but basically it means the ability to add something to a call that's in progress. So for example, the ability to press a button, let's say the star key, and have the call start recording. And then when that recording is finished, maybe you could go to a website and download that recording. Or maybe even a translator comes behind and transcribes the entire call, so you can download the text of the call as well as the recording. You can also enable or disable, for example, voice masking if I wanted to sound not like my normal self, maybe if I'm a whistleblower. I could turn on some kind of voice transform. Or even better, if we had the ability to listen into the phone, to the audio stream, and pick out hot words, so we could detect when someone started talking about Christmas, or we wanted to hear when they started talking about maybe a calendar appointment next week. If we can detect those occurrences, we can do things like add them to a calendar or make other decisions about what to do with the call. I've also heard of cases where you can detect when someone is getting frustrated. So maybe if they're on the call with a customer service agent and they're really not getting their problem solved, you can get some kind of feedback automatically that says, this person's getting frustrated, let's transfer them to someone else, maybe we can solve their problem a better way. Another example of voice application would be CRM integration. We did a demo a while back where when a call would come in, we would take the caller ID, so we knew who was calling, look it up in a look up in a CRM, customer relationship management system, find out who the customer was, go and pull a list of tickets, go and pull a list of invoices, find out if they were current on their bills, and then send all that information in the form of an instant message to the salesperson taking the call. So suddenly they had a ton more information on their screen than just the simple caller ID. They knew the context who was calling. If they had tickets open, they probably even knew why they were calling. They knew the last time they called. These things are very easy to integrate these things are very easy to create when you have the ability to talk to all of these backends. And then there's another term, over-the-top services. It's kind of a buzzword, but what it means is, again, as I mentioned, pressing a button to start a recording and get a transcript automatically. Another possibility that's pretty cool, especially with mobile devices now, is location services. So being able to tell when you get a call where the person is calling from, and not just the phone number where, but actually where the device is located in the world. You could then take that and generate a map of all your calls and get a sense for, well, you've got a hotspot of calls coming in from this area. So those are some possible applications you can build. What I'd like to talk about next is why adhesion is the modern approach to building these things. So as I mentioned before, Adhearsion is a voice application framework. As far as I know, it is the first of its kind in the open source world, and of a very short list of competitors even in the commercial world. Usually with voice applications, what we have are libraries, very simple little components that let you talk to one specific backend. A framework is much more than that. I'm sure many of you in here are familiar with things like Cake PHP or Ruby on Rails. Those frameworks provide an entire context for programming. In the case of Adhearsion, we provide things like logging, a consistent logging interface that can channel logs and separate them by call or separate them by the context. A plugin system so that you can easily go download additional functionality and incorporate them into your application. Rather than reinventing the wheel each time, use a plugin. Fault isolation. This one's important. If you're building something that one fault will bring down the entire engine, that's bad, especially in the case of a phone call. If you have one bug where you have an uncaught exception and all 17 phone calls in progress go down, that's a problem. By putting these things into Adhearsion, first of all, we isolate the faults internally, but also it separates the telephony layer from the logic layer. I'll talk more about that in a second. The framework also takes care of grunt work like daemonization and threading for you. We take care of all the ugliness around the startup and recording the PID file, managing the threads so that each call is executing in its own context. And you don't have to deal with any of that. You just have a handle on a call object and you interact with it. We also take care of all the connection management, so connecting to the various backends. At a minimum, we're talking about connecting to the telephone system, but also connecting to things like databases like LDAP, like IRC servers or XMPP servers. But I think the biggest thing, the most important thing that Adhearsion provides is a common way of doing things. Just like there is the Rails way of building an application, there is an Adhearsion way. And anyone who's built an Adhearsion application can largely look at another Adhearsion application, understand what's going on, understand how we approach a problem, what the best way to approach a similar problem might be. So this is a little bit about the architecture of Adhearsion. As you can see, we have at the very top we have a phone call coming in, and we have two telephony engines. We have Asterisk and, in this case, Tropo. So you all have heard of Asterisk. In case you haven't, I'll just mention it's a open source, called the open source PBX. And what it does is it takes calls in from all different kinds of media, whether those calls are old school TDM, those expensive networks I talked about before, whether they're SIP, whether they're any of a handful of other more exotic voice over IP protocols. Takes all of those in and provides an API that Adhearsion uses to interact with those calls. We also support Tropo, which is a cloud-based telephony service. You guys probably have heard of Twilio? Some of you? So Tropo is like Twilio. They're lesser known, but in my opinion, way more capable. They have better text-to-speech and things like this. But what's important from the Adhearsion standpoint is that we can integrate with it as well. So if you don't want to go through the hassle of setting up your own Asterisk server and you want to experiment, Tropo is a good way to do that. So the call comes into one of those two telephony engines, and it connects down into Adhearsion. Right now, that's primarily using an Asterisk protocol called AGI, which is stands for Asterisk Gateway Interface, sort of conceptually similar to old school CGI applications. But the connection comes in, it runs over the network, so you could run Adhearsion on the same machine as Asterisk, or you can run it somewhere else in your environment. And then Adhearsion looks up the source of the call, decides what to do with it, you applies whatever program you have created, but it also connects automatically to these backends. We have canned connectors for things like Ruby on Rails, just about any SQL database, anything supported by Active Record, which is the Rails database abstraction. We have connections to LDAP, of course, to XMPP, and then it's very easy to connect to any kind of web service, consume a URL, send or get JSON or XML. So all of these things will flow back into Adhearsion, and then you can make your decisions based on that. The important thing here is that it really decouples the logic from the engine. As I mentioned earlier, you wouldn't want a fault in one part of a phone call to bring down the entire system. One thing that has plagued Asterisk development over time is that when you're writing an application that runs inside of Asterisk, you're writing it in C. And C is not necessarily the easiest language to write, so you have to deal with memory pointers and you get off by one, and it's very easy to segfault. And unfortunately, when you do segfault asterisk, it does bring down the entire system, so all those phone calls get dropped. By decoupling, you get the ability to leave the time-critical, the hard parts, the media, leave that to the engine. We don't want to get into transcoding. We don't want to get into dealing with audio codecs and audio stream. What we care about is actually handling the control. So asterisk provides us an interface upward, and we consume that interface in the Adhearsion world, and those two processes are completely independent of each other. If you do crash Adhearsion, all of your asterisk calls that are in the system will not go down. They continue to process, maybe the application is down, but at least the phone calls themselves are still up. I liken this to, also, you probably wouldn't sit down and try to write Facebook in C. That would be probably considered pretty crazy. It's just not an expressive enough language. You can't move fast enough. Writing in something like Adhearsion with Ruby, you can be much more expressive. You can prototype much more quickly, and you'll be up and running much more quickly. So I've dropped some hints. I should probably go ahead and let you know. Adhearsion is written in Ruby. It's a modern language with a modern DSL. So Adhearsion provides a domain-specific language. We provide a lot of primitives that you can invoke on a telephone call that allow you to interact with it. So when a call comes in, you say answer to answer the line, or you say play and then pass it a sound file. It's a very natural way of interacting with it. And in fact, when you sit down to read an Adhearsion application, what you'll see reads very naturally. It reads like it's expressive, so you can understand the intent of the program without having to understand the implementation details. This also allows us to apply modern development practices. As I mentioned, Adhearsion being the first open source framework for voice, telephony has traditionally been a very closed development ecosystem. You had to have whatever SDKs were made available by the manufacturer, and it was hard to apply good development practices. One of our favorite things about Adhearsion is the ability to apply unit testing to telephone apps. This was unheard of a few years ago. But the ability to take the logic that applies to my phone call and run it through a series of tests and determine programmatically whether I've broken something when I make a change, that's kind of revolutionary. It's a bit old hat to those of us who do this every day, but to the telephone world, it's amazing. And so this is a very powerful thing. Also, automated deployments. Again, we have the ability using tools that were developed for other domains. In our case, we largely use Capistrano, which is a common tool for deploying Rails web applications, or web applications in general. We can apply that to the voice world. Again, it may seem sort of familiar to you if you use it every day, but this just wasn't possible. Now we can deploy these telephony applications, voice applications with Capistrano. And for us, this means we can apply Agile. And this is a win for everyone. This is getting features out the door every week or every couple weeks rather than 6 months or a year. This is being able to react to changes in the client's requests, the demands of the application in a few days rather than spending hundreds of thousands of dollars and prototyping something that ends up not working. So, of course, this is FOSDEM, and perhaps the best part of this is that the entire stack, all of it is open source. Adhearsion itself is open source under LGPL. It's written in Ruby. Runs on top of Asterisk, which is itself open source. Most cases you're deploying Asterisk on Linux, although there are cases that we actually have people running it on Solaris as well, which is open source. And XMPP not only is an open protocol, but has many open source server implementations. Now, I pause a little bit about XMPP to let you know that everything I've explained up to date largely deals with the current released stable version of Adhearsion, Adhearsion 1. It's been basically API compatible since 2008. And this year actually, late last year, we started working on the next version of Adhearsion, Adhearsion 2. We're going to break API compatibility for the first time. And it's got some pretty exciting new features, the biggest of which is support for this Rayo protocol. So I'm going to talk a little bit about what Rayo is. Rayo is something we've been working with a company in Orlando called Voxeo to create. It's a specification for third-party call control. So third-party call control is what I've been describing for this entire presentation. It's a process sitting outside the telephone engine. It communicates with the telephone engine to do the things like set up calls, answer them, route them, interact with the voice, put people in the conference, those kind of things. Rayo is an open specification. The server implementation that has been created is open source. The first client implementation, what we've created in Adhearsion 2, is open source. And the spec itself, we haven't yet submitted it, but is due to be submitted hopefully by the end of this month. So that will be the first, as far as we know, completely open standard, real-time, third-party call control. And all of it runs over XMPP. So the reason this is really cool, the reason why this is exciting is, so far voice applications have been in the realm of individual companies or organizations who want to create applications on phone networks they already control. Or maybe, to extend that a bit, to build voice applications that interact with cloud communication services, such as Tropo or Twilio. But we have an opportunity now with Rayo to extend that control to a much, much bigger network. Everyone in who has a cell phone through a major carrier, whether it's Telefonica or AT&T or T-Mobile or whatever. Your cell phone is, because of the cost of entry, because of the barriers to actually becoming a cell provider, it's unlikely that you're going to get the corner cell phone provider in the near future. So it's going to be increasingly important both for the carriers, who are quickly turning into nothing more than basically dumb pipes to move calls around. It's going to be important for the carriers. It's also important for developers to have a way to interact with this enormous network of calls that are going on, and to offer all of these cool services that I've been talking about this whole time to people who have nothing more than a cell phone in their pocket talking to other people with a cell phone in their pocket. This is what Rayo does. Rayo can be deployed into the network, inside a carrier, inside AT&T, inside Telefonica, and allow an outside third-party developer to create a voice application and apply those to calls running inside the carrier. So because Rayo is built on top of XMPP, you have built-in things like federation. You have a security model. You have authentication. All of these things are things that make a carrier feel much more comfortable that they can control what's going on inside their network. But at the same time, it's kind of subversive. It's cool in the way that this allows all of those control mechanisms to be extended outside the network. So if you have a phone and you authorize me as a developer to have some control over your call, I can start providing these services to you with nothing special. You just go to the website and sign up and give me your phone number, and then I can apply these things. So a friend of mine, Jose de Castro, who's one of the authors of this Rayo protocol, he has some pretty cool examples. You have a phone in your pocket and it probably has a button or at least a mode where you can turn it into silent versus on. What if that became a form of presence? What if we could take that switch, the state of that switch, and make a decision as to whether to send you the call based on whether you are in silent mode or not? Maybe you're sitting in a meeting and you've got the phone on silent, and most calls are not all that important. Maybe it's a reminder call from a dentist, and it's not terribly important that it disturb your meeting. Well, maybe we can check the state of that ringer and decide that call should really go to voicemail. These are things that are only possible if you reside inside the carrier. And so Rayo is I think, the next thing that's going to revolutionize the way that we deal with our telephones. And the good news is it's all open. So I went through that a lot faster than I thought I did. But this is the Adhearsion project. You can see our website and GitHub repositories. We also have contact information for Twitter. I did not choose to show code samples today because I wasn't sure how many of you are Rubyists, but I would be happy to do so now. But if you have any questions or if you would like to see examples, I'd love to hear them.
How you work email let's say with the ability for being your telephone number, having it in the DNS, and allow us to choose where calls are routed, or actually what the end user that is calling you routes its call by itself.
Yes. So the question is, am I familiar with enum? And for those of you who aren't familiar with enum, it's a system by which you can register your phone number essentially in DNS. And this makes it possible to, just as you look up the IP address of a website, you can look up a phone number and determine what endpoint is responsible for handling that call. Yes, we do. And Asterisk has support for enum. Adhearsion, you could easily implement support for enum. Going back to the slide I had about federation, the next 10 years that we will start to see more federation, I believe enum is a critical part of that. So yes. Yes.
Two things for you. Firstly, where do I get things like text-to-speech and speech-to-text, and are there any good open source ones? And secondly, just quickly looking at the website, it makes reference to something called Prism. Is that the server-side implementation of Veil?
Yes. So let me answer the first one, and I'll come to the second one. So there are two parts to the question. The first was, where do I get text-to-speech and speech recognition, and how do I use it? So, and are there any open source ones? So the first part of that, let me go back to the slide here. Asterisk itself does not ship with any text-to-speech or speech recognition. It does have connectivity to several. Off the top of my head, there are Festival, Kepstrel, NeoSpeech, Flight, and CMU Sphinx. Of those, the only ones that are open source are Festival and Sphinx. And their quality is not great, unfortunately. Today, to get really good quality text-to-speech or speech recognition, you have to license it. The one exception to that, and it's not a great exception, but anyway, Tropo, because it's all cloud-based, they take care of all that for you. So when
So just pay a bit for that.
in Tropo's case, you pay a flat per minute rate, and then their entire platform of features, including text-to-speech, and speech recognition, are available as part of the call. So if you were to go on a purely open source platform, you could do it, you would just have to license, either accept the lower quality of the open source implementations or license, you know.
And in Adhearsion, I can do something like, say, speak this, and it will go off and tell Tropo to render it to voice.
Right, so I mentioned the DSL earlier. Our implementation has an abstraction called the speak method. And the speak method knows what kind of backend you're connected to. And you configure it whether it's Kepstrel or whether it's NeoSpeech or whatever. And so you just say speak and then a string, and it will take that string and pass it off to the right backend. Now, and on top of that, you can also pass what's called SSML, which is an XML markup called Speech Synthesis Markup Language, and allows you to control lots of things. You can control intonation, you can control the gender of the voice that's being read back, you can control the speed or even the pace of the text. Okay, so the second half of your question is, what is Prism, and why is it relevant here? So Prism is a commercial product created by Voxeo, the company that builds Tropo, also the company we're partnering with on the Rayo protocol. Prism underlies Tropo as well as a lot of other things that Voxeo does. It also is, it's a SIP servlet container. In the open source world, there's a similar one called MobiSense. The only thing that, to my knowledge, that Prism does that MobiSense does not do with regard to what we've covered today is that Prism has a XMPP servlet container that goes with the SIP servlet container that makes it possible to do the Rayo protocol. I would love to see the MobiSense guys get on the Rayo train, and I think that if they end up putting a XMPP container in, you'd be able to go that entire route with Rayo as well. But it's a commercial speech engine, or I'm sorry, a commercial voice application engine. It would take the place of Tropo or Asterisk in this diagram.
Thank you very much.
Sure. Yes.
Tropo know that because they still offer evolution and it's still more popular than anything else. So, you know, I'm not saying you should try and send the virus to the big industry that's behind all those NDAs, but if you want something like Adhearsion to really, and to a certain extent Asterisk, to become really big, you have to attack them through the voice XML, CCXML vector.
Okay, so his statement was that the establishment essentially uses voice XML, and that is the way of doing things. And to have an effective presence, to be able to affect any kind of change, you need to be able to, I suppose, disrupt or at least be compatible with voice XML. Is that what you're saying? So I see your point there. I'm not sure I entirely agree. Adhearsion is a different paradigm for programming than voice XML. Kind of the intent behind voice XML is similar to HTML. I have a document that represents whatever it is I'm trying to express. And all of that is, with a few exceptions, all of that is calculated ahead of time. I think that some of the problems that are inherent in voice XML are similar to some of the motivations that led us to create Asterisk. And by that I mean VXML is a document, but it contains a programming syntax within it. There's a type of exception handling within XML. To me, that makes my head hurt. I don't quite understand how a document can have a programming aspect to it. And I think that partly that's why this is a better approach, because this is applying the right tool to the right job. We want to be able to create sophisticated functionality. Let's do that in a programming language where we have more control over how that works, and the ability to use modern development tools and exception handling, real exception handling. As I mentioned, unit testing. All these things are not really possible, at least not meaningfully like this with VXML. But to your point about whether it's possible to disrupt the industry, certainly using standards is an easier avenue in, but I think that because our vision of how it should work is so different, trying to cater to voice XML would undermine too much the kind of things we're trying to express. So I see your point, but I think that the possibilities here are much more powerful than simply disrupting VXML. What other questions do you have? Do I have any Rubyists in the audience? No Rubyists? Wow. I've been doing too many Ruby presentations. Well, all right. Is there a C API? Ruby has a C API. If you do need something that is only has a C library, you certainly could create a C module for Ruby. Adhearsion itself does not have a C API. It's just it's a framework more than a library. Okay, well, thank you all very much.